So this is a problem that appeared in Indian National Mathematics Olympiad 2017. It was the fifth problem on the test and the question is from geometry. So let us go through the question first and try to understand what is given in the question. Let's make the diagram also. Let ABC be a triangle. So we have a triangle here and angle A is 90 degrees. So it is basically a right angle triangle. And AB less than AC. Okay, that is fine. Let AD be the altitude from A onto BC. So this is the altitude and this angle is 90 degrees. So before moving further into the question, so let us analyze this part of the figure first. So let this side be C and this side be B and BC. Let BC be A. So now we have A square is equals to B square plus C square because it is a right angle triangle. So let us find out AD. What will be the length of AD? So AD into BC into half. This is the area of the triangle. Half into AC into AB. This is also the area of triangle. So AD is equals to AC B AB C by BC. So AD is BC upon A. So AD is equals to BC upon A. Let us also find out BD. BD square is equals to AB square minus AD square. So C square minus B square C square by A square. So C square into A square minus B square upon A square. A square minus B square is C square. So C power 4 upon A square. So BD square, BD is equals to C square upon A. BD is C square upon A. Similarly, BD is C square upon A. Similarly, CD will be B square upon A. Alright. So let us keep these things aside and let us move ahead with the question. Now, PQI denote the respective incenters of the triangles ABD. So P is the incenter of this triangle, Q is the incenter of this triangle, and I is the incenter of the bigger triangle. Alright. So let us try to locate the positions of these incenters first. So let us draw the angular bisector from angle B and the angular bisector from angle C. So these two will intersect somewhere here. So this will be I, correct? And P is the incenter of triangle ABD. So P should lie on the angular bisector BI. So let P will be somewhere here. And similarly Q should lie on CI. So let us say Q is somewhere here. Now what do we have to do? So if it is P, so this distance will be R, and let this point be P1, and this distance will be R1. Let us say R1 is the in radius of triangle ADC. Then this distance is also R. This distance is also R1. So R1 is greater than R. Why? Because it is given in the question that AB less than AC and AD is the common side. So DC will be greater than BD. From here also we can see that. CD will be greater than, so AB less than AC means C less than B. Since C is less than B, BD will be greater than, BD will be less than DC from these formulas. So one side is common for both the triangles and the other two sides of triangle ADC are bigger. Hence, the in radius will also be bigger for triangle ADC. That is why the position of Q is little above the position of V. Now consider triangle PIQ. Triangle PIQ. This is triangle PIQ. And let us extend, let this point be P2 and let this point be Q2. Let this be Q1. So let us extend P2. So this meets it here. Let this point be P3. Now consider triangle Q P3 P. It is a right angle triangle. Angle Q P3 P is equals to 90 degrees. Correct? Let us find out what is PP3. PP3 is PP2 plus P2 P3. So PP3 PP2 is R plus P2 P3 is nothing but QQ2. Correct? So this is R plus R1. Alright. And let us find out QP3 as well. QP3 is equals to QQ1 minus Q1 P3. QQ1 is R1 minus Q1 P3 is same as PP1. So this is R1 minus R. Alright. So we have these two results. Now let angle Q. So let us redraw the figure here. So I'll summarize these things. So PP3 is R plus R1 and QP3 is R1 minus R. So this is R1 minus R. Alright. So now we have to prove that AI is perpendicular to PQ. So I'll draw the diagram here again once more to get the idea. So this is our triangle IPQ. So we have this triangle here. This is P3. So this PP3 is parallel to BC, correct? Let this angle be theta, right? Let us join A and I. So let the angle made by AI with this be alpha. So if this angle is alpha, this is also alpha because PP3 and BC are parallel, right? So we have to find out so with PP3, PQ is making some angle and AI is making some other angle. So if the difference of these two angles is 90 degrees, then we can say AI is perpendicular to PQ, correct? So we'll do that now. We'll find out those angles. So this angle is theta. Then what is tan theta? Tan theta is equal to QP3 upon PP3. QP3 is equals to R1 minus R. P3 is R1 plus R. Now let's connect A and I. Let's join A and I. This angle is alpha. So we have to find out alpha. So let this point be E. If we consider triangle AEB, then sum of angles is 180 degrees. So angle ABE will be B, and this angle will be A upon 2 plus this angle is 180 minus alpha, that is equals to 180. So alpha is equals to B plus A upon 2, correct? So alpha is B plus A upon 2. So we have this angle, we got this angle. Now what do we have to do? We have to find out this theta and then we have to subtract them. If the difference is 90 degrees, then we can say AI is perpendicular to PQ. So let us find out what theta is. So to do that, we have to find out R and R1. R is equals to the area of triangle. So let's say the area of this triangle is delta 1, this triangle is delta 2, and this semi-perimeter is S1, its semi-perimeter is S2. So R is equal to delta 1 by S1. Delta 1 is half into BD into AD by AB plus BD plus AD into half. This is a semi-perimeter. This will get cancelled. So BD into AD. BD is C square upon A into AD is BC upon A by C square by A plus BC by A plus what is AD? AD is, sorry, AB. AB is C. So this is R. So after simplification it will be BC square upon A into A plus B plus C. Is that correct? Yeah. BC square by A into A plus B plus C. Similarly, if we find out R1, so that will be B square C upon A into A plus B plus C. Okay, now let us find out tan theta. Tan theta is equals to R1 minus R upon R1 plus R. So plug in the values of R1 and R in this equation. So then it will be B square C minus BC square upon B square C plus BC square. So take BC is common, so it will be B minus C by B plus C. So tan theta is equals to B minus C upon B plus C. Now what is B? So from the sine rule, B will be 2R sine B minus 2R sine C upon 2R sine B plus 2R sine C, where R is the circumradius of triangle, circumradius of triangle ABC. So this will be sine B minus sine C by sine B plus sine C. But B plus C is 90 degrees. Since angle A is 90 degrees, angle A is 90 degrees, so B plus C is 90 degrees. So C is equals to 90 minus B. Put C is equals to 90 minus B, then sine B minus sine 90 minus B, that will be cos B by sine B plus cos B. So divide the numerator and denominator by cos B. So this will be tan B minus 1 by tan B plus 1. So this is tan theta. So this can be written as tan theta is equals to tan 45 tan B. Sorry. This can be written as tan B minus tan 45 upon 1 plus tan 45 tan B. So this is in the form of tan A tan B minus tan A minus tan B by 1 plus tan A tan B. So that will be tan of b minus 45. Correct? So theta is equals to b minus 45. And here we got alpha is equals to b plus a upon 2. Alpha is equal to b plus a upon 2. Correct? And what is a? Angle A is 90 degrees. So this will be b plus 45. So alpha minus theta will be b plus 45 minus of b minus 45. So that is 90 degrees. Therefore, AI is perpendicular to PQ. So this is the first part of the question, and we also have to prove AI is equals to PQ. Okay, AI is equals to PQ. Okay, let us do that. First, let us find out PQ. So in triangle, so to find out PQ, we can apply Pythagoras theorem in this triangle. Right? So PQ square is equal to PP3 square plus QP3 square. Alright? So we will do that. So PQ square is equals to R1 plus R whole square plus R1 minus R whole square. So that is equals to 2 into R1 square plus R square. So we have already derived R1 and R here. So this is R1. Sorry, this is R and this is R1. So we'll put that, we'll plug the values of R and R1 into this equation to find out PQ. 2 into R1 is B square C. So B power 4 C square upon A square by A plus B plus C whole square plus B square C power 4 upon A square by A plus B plus C whole square. So this will be twice of, so B square C square will be common, B square C square by A square into A plus B plus C whole square into, so here it will be B square plus C square, but B square plus C square is A square, so this and this will get cancelled. So 2B square C square upon A plus B plus C whole square. So this is PQ square. Now let us find out AI square as well. A is the vertex and I is the incenter. So what is AI? AI will be R cosecant A by 2. Correct? AI will be R cosecant A by 2. And R will be delta upon S, and cosecant A by 2 is cosecant 45. Delta upon S. So what is delta? Half into area of the bigger triangle, B into C. B into C by S is half into A plus B plus C into cosecant 45. Sin 45 is 1 by root 2. So the cosecant 45 is root 2. Right? So this and this will get cancelled. So this is root 2 BC upon A plus B plus C. So this is AI. And from here we have PQ square. So from this, if we find out PQ will be root 2 times BC upon A plus B plus C whole square. Sorry, A plus B plus C. So this is PQ. So PQ and AI are equal. So hence we conclude AI is equals to PQ.